Okay, so let's look at this assignment quickly. Amira has started with it, but Ibrahim, you haven't. So we just scan through this. Okay, this is like peanuts, the first one. Length of the line, midpoint, gradient. What? PQ doesn't have a gradient. I hope you can see that. So it'd be 0. It's actually, the gradient isn't defined. Okay, equation PQ. Why did they do this? This is a real funny example. Can you see that, Amira? The x values are the same. So this is not a real example because your gradient will be 8 minus 2 over 3 minus 3. That's like undefined. Anyway. Same here. Really? This gradient will just be 0. Okay. These lines don't have any gradient. Yeah. Are you familiar with equations for lines that are parallel to the x-axis and parallel to the y-axis? Just speak to me quickly. Or do we have to look at that?
We have to look at it.
Okay. Okay, we'll look at that today. So nothing, there's length you can do, midpoint you can do, gradient, this equation might be a problem. What conclusions do you make about horizontal and vertical lines in terms of the equation as well as their gradients? Okay, good. You'll make that conclusion afterwards. It's easy. Okay, now we're starting with a proper example. Okay. You must finish this weekend. So next week you might have questions on it. I'm just scanning through. Yeah, there's nothing here that's difficult. Okay, let me just do that quickly. So let's look at a straight line graph and then we can do some examples on. So there's my system of axes. Now, this is the y-axis and this is the x-axis. So if I have a line that's parallel to the x-axis, that can give you a coordinate there. Let's say that coordinate there is A, and that is 2 and 5. Then the equation would look something like this. Y equals mx plus c. But there is no gradient. No. You can figure out the gradient if you want to. The y-intercept here is 5. But if the line's parallel to the x-axis, there aren't any gradient. So the equation will just be this. Y equals 5. You can actually physically go and work out the gradient if you want to. The gradient is the y1 minus y2 over x1 minus x2 value. And the one y value there will be 5 minus the y value there is 5, which is 0. And then I have 2 minus 0. That's just 0. So there is no gradient. Is that kind of logic? So that's for a line parallel to the x-axis. Amira, you knew this?
Yeah.
Okay, then Ibrahim, check here. What about a line that's parallel to the y-axis? They can give you a coordinate here. Let's say that one, -3. So it actually looks like this, y equals mx plus c, but there isn't any, what? There aren't any y-intercept, so there's no c value. There's no gradient either, so your x value will always be -3, and that's that equation. The gradient is actually undefined. Is that easy? So they could have done this, doesn't matter. They could have just given you a coordinate there. Let's say -3 and 6, doesn't matter. There's no gradient and the x is always -3. Anywhere on that line, the x value is -3. And that is not difficult. Okay, so that might be new if, or you have done that in grade 9 and you haven't looked at it in grade 10 and that's why you forgot it. Okay, let's go over to analytical geometry and we do some examples. Okay, take a pen and a paper and quickly make that drawing. And also fill in the values. And then maybe just highlight this. Okay, so there's a RSPQ is a parallelogram, basically. They don't have to tell you that. You can see that on the drawing. And then the equation of the line QR is 2y. Let's write that. QR is 2y minus x minus 16 is 0. And I hope you're going to just put that into its standard form. There's the standard form. Right, quickly do that. I'll give you a minute to make that drawing.
Okay, I took it down.
Okay, Ibrahim, got it?
I almost.
I mean, you're just going to test the basics. So question 1. I want to know what is the coordinates. No, let's start with something easier. I just want to know what is the equation of the line SP. Quickly do that. What would the equation of the line SP be? What is the equation of the line SP? Do you know how to do it?
Don't you use the formula of y equals to mx plus c?
Y equals mx plus 1. Okay, Ibrahim, are you back? No, not yet. Ibrahim has got internet problems. Okay, good. Then help me, Amira. What's next?
Gradient, isn't it, with the m?
Yeah, what is the gradient?
Won't it be 5 minus 0 over 4 minus 0?
No, where do you get 0? We don't have S's coordinates. You see that?
Oh, yeah.
Okay. We don't have the coordinates of S, but we have 2 parallel lines. You see that? What is parallel line? Ibrahim, are you back? Look at this. The first question is, what is the equation of the line SP? Now, look at this, Amira. We can't use the S coordinate to determine the equation, the gradient, but we can go and steal the gradient from that line RQ, can't we? Because they are parallel to one another. So the gradient is just a half. Come, why is that? Help me. Why is a half? Because M1 equals M2, isn't it? Parallel lines. If the 2 lines are parallel, look, that's a parallelogram. So RQ and PS is parallel to one another, and therefore they have the same gradient. So I can just go and steal the gradient that I work. They gave me the equation of the line QR, and I just put that into standard form. So now I can actually just steal that gradient. Happy with that, Amira?
Yeah.
So the equation is y equals a half x plus c. And then I have to find one coordinate on that green line, the coordinate p, and put that in 4 and 5. So now I have 5 equals a half times the x value of 2 plus c. 5 equals 2 plus c. C is 3. Quickly, take that down, write it down, or snap it.
Okay, I got it.
Okay, Ibrahim's gone. Right, next question. Okay, we're inventing our own question. So I'm just gonna just make that and make this smaller. The next question would be what do you think? What type of questions can we ask just to get all the standard stuff done? I can also ask you now, what is the coordinate of C? No. S. What is S's coordinate? See, we've got that line SP as y equals a half x plus 3. Well, we didn't write that out. Y equals half x plus 3. So how can I get the coordinates of S? Can you help me?
Mm,
How do I get the x-intercept of any graph? The x-intercept of any graph you can get how? That's the x-intercept. Okay, if you want the x-intercept, you make y 0. If you want the y-intercept, you make x 0. Why? On that line there, on the x-axis, y is 0. So I'm going to take that equation, y equals a half x plus 3, and I'm going to make the y value 0 to get the x-intercept. So 0 equals half x plus 3. Okay. Negative half x is 3. So I multiply with negative 2. Then I get x is negative 6. So my S coordinate is negative 6 and 0. This should not be difficult because this is analytical geometry, exactly what you did last year, and it also is the same as straight line graphs because you're getting equations now. Quickly dot that down. That's quite important. Dot down the question and also the memo or the answer.
Done.
yeah, same with me.
Amira, done?
Yeah.
Okay. What you also need to have with you is all the analytical equations. So my next question you're going to need equation for. I want to know what is the length of RQ. Question 3. What is the length of RQ? Just think about it, write down the question, and then you tell me how you're going to do that. Maybe you can start off by giving me a formula or a method.
To work out length, you'll use the distance formula,
Okay.
but then you also need the coordinates of R.
Okay, but you actually don't. Think about it. You don't have the coordinates of R, do you?
Mm-mm.
But isn't RQ and SP the same length? Because it's a
Yeah, the
parallelogram. So you can say
yeah.
RQ equals SP. What? Opposite sides of a parallelogram. Now, that means I
Yeah.
don't have to get RQ's length. I only need to get SP's length. And SP, I've got 2 coordinates. I just got the coordinate of S. So now I can fill in those values. You have to go and practice analytical geometry in your textbook. It's -6 -4, the two x's, the difference between the x's. And then there's a 0 -5 for the y. I want you to put that in a calculator and leave it in root form. Is it 5 √5?
Yeah.
Okay, good. It's going to make it smaller, some of the stuff here, so we can actually, otherwise I need to copy this out. Okay. So what we've done is the following. We've actually calculated the length of SP or RQ. That was 5 √5. We got this coordinate as, was it -6?
Yeah.
-6 and 0. And we got the equation here. Half x plus 8, and the other one was half x plus 3. So RQ is y equals half x plus 8, and the other one is half y equals half x plus 3. This is SP. And then we have both of those lengths. Okay, now, question number 4. I want to know what is the angle, what is the inclination angle of PS? What is the inclination angle again? We did that last week. Inclination angle is the angle that the line makes with the positive side of the x-axis. So in effect, I want to know what is the angle alpha's value. And the equation you use is that tan alpha is m. Quickly do that. I want you to be able to do this analytical geometry work very quickly. This is easy math. Okay. Answer.
Tan alpha equals to 5/6.
No. Tan
Go for
alpha equals, what is the gradient of that line? It's half. We got the gradient. There it is. Remember, inclination's angle, you have to go and rewatch the video on this, is the line it's that line with the positive side of the x-axis. So what do we have there? Alpha is what? Shift tan half. It's important that you be able to do this. 26,57. Don't mess it up now. You've been doing really well with the previous work that we've done. The analytical geometry is a very easy part of the work, but you have to go and practice it. Okay, so that's 26,57. Okay, awesome.
Yes.
Good. And then I'm going to do something harder. What is the coordinates? Okay, what is the coordinates of R? Okay, I have to teach you something. What is R's coordinates? How would I find R's coordinates? Just tell me that, okay, if you don't know.
Wouldn't it be the distance between Q and R or something like that?
Yes. Okay, awesome. That's one way of doing it. Okay, let's do this as example. That's very good, Ibrahim. There's two ways of doing it. So we don't need any of the other stuff. So let's just work on this. I want to know 1. What is the coordinates of R? That's just a short way of asking what's the coordinates of R. Now, Ibrahim suggested the following. This was -6 and 0. So he suggested the following. He said, look, there's some movement here. Look at this movement. I'm going 5 units down and I'm going 10 units back. Can you see that? From 5 to 0, that's where S is. There's a triangle there. 5 to 0, I go 5 down. And from 4 to -6, I'm going 10 back. I do exactly the same with Q. I go 5 down. So 6, 5 down gives me what? A Y value of 1. And from 2, 10 in that direction goes to -8. That's R's coordinates. So I just did inspection. That's one method. Can you see what I've done? You could have also done it. Well, you can also have done it slightly different. You can just move with the other legs or the other sides. I can say, look, from Q to P, I'm moving 2 to the right. And I'm moving 1 down. Okay. Or, yeah, let me just do it the other way around. It's going to be easier to visualize. So from P to Q, I'm moving 1 up and 2 left. So from S, I'm also going to move 1 up and 2 that way. So from 0, 1 up gives me a Y value of 1. And from -6, 2 to the left gives me -8. So you can also work on those sides. That's your inspection method. Okay, there's also an algebraic method. Sorry, you didn't write this down, did you? You can snap that. If you like this method, if maybe you've got like CAT or something and you're used to drawing lines and stuff, this would be an easier method or easy method. Then there's a longer way, but this is how you work with parallelograms. The only parallelogram rule that you have to know is that these two bisectors intersect at the same point. So they have the same midpoint. Again, we have -6 and 0 there. So I can do it this way. I can say, look, I'm starting with QS. And the midpoint is the 1x plus the other x value divided by 2. And the 1y plus the other y value divided by 2. So let's get the midpoint of QS. It's a longer method. So this is -6 plus 2 over 2 and 0 plus 6 over 2. So that midpoint value is -2 and 3. So I've got the midpoint value there. The mid of that line. Now that midpoint is the same for the line PR. In other words, the line PR, there's P, that is 4 and 5. And it also has a midpoint value of -2 and 3. And it's got an R value of X and Y. So they are also the same length. So now I can say the following. This X plus the 4. So X plus 4 divided by 2 is the X value in the midpoint, -2. I multiply with 2. We did this last week. X plus 4 is -4. So X is -8. Let me just write that slightly neater. X equals -8. We can also determine the Y value. The 1y plus the other y over 2 gives me the Y value in the middle. Multiply with 2 right through. Y plus 5 is 6. 6 minus 5 is 1. So the coordinate of R is -8 and 1. Exactly the same we got. This is just the algebraic way to do it. So this is like method 2. Quickly dot that down or snap it. Photograph it, in other words. Okay. Amira?
Yeah.
You need to, you're bright, and Ibrahim, you're also bright. You need to both get the analytical geometry You have to get it done and dusted. It's the easiest part of all your paper 2 stuff for the year.
Okay.
Because trigonometry and the Euclidean geometry is quite involved. Okay, tell me when you're finished.
Yeah, I took it down.
Done.
Got it. Okay. And that's about it they can ask. We can make it harder if we want to, but just do another example rather. Okay, there we go. Quickly make a drawing. Make that drawing and we'll make up our own questions. I don't know what they've got R there. We'll make up our own questions. Doesn't matter really. Can you tell me when you finished?
Done.
Yeah, done.
Okay, first thing, let's just get all the basics done. The first question is, I want to know what is the length of SQ. There you go, on your own. What is the length of SQ?
Do you use your distance formula?
Yes. You start SQ equals x1 minus x2 or 2 minus 1, doesn't matter, plus y minus y squared.
Is the answer 2√29?
I think so, yeah. Okay, let's do that. So I'm going to use this one is number 1 and that one is number 2. It doesn't matter. You can swap it around. So we have -5 minus 5 squared plus 8 minus 4 squared. Is that 2√29?
Yes.
Awesome. Okay, good. I want the equation of QP too. What is the equation of the line QP? Standard stuff. Y equals mx plus c. You'll have to get the gradient first. On your own, go. You have equation for the gradient, you have equation for the line.
Is it 1?
Now the equation can't be 1. So we first need to get gradient. The gradient is y minus y over x minus x. So I don't have the gradient, so I first need to calculate it. So the gradient is what? 4 minus 2, is that right? Over 5 minus 1. Okay, but the gradient is 1 then, yeah. Not the equation, the gradient. That's 1,
Yeah,
eh?
gradient.
Mira?
The gradient.
Yeah, so gradient's 1. Therefore, y equals 1x plus c. And now I need to just put in one of the coordinates. Well, I'll put in q. The q coordinate is 5 and 4. 4 equals 5 plus c. Minus 1 is c. So the equation is y equals x minus 1. That's the equation of the line QP. Awesome. Do you have it?
Yes, sir.
What's wrong with Amira today? Amira is not talking.
She's feeling
No, I was
sick.
checking my answer, but it's right.
You don't have the answer.
No, I have the answer. It's right.
You're not allowed to watch Netflix while you are in class, Amira.
No, no. I was checking my answer.
Okay. Good. Okay. I want the following. I want you to, we're just gonna play around. I want you to get the midpoint of SP. What is the coordinates of the midpoint of SP? We'll make it harder just now. I'm just gonna play around.
What's a midpoint formula?
It's the only one with the pluses in. So it's the 1x plus the other x. So let's say 1 and 2 divided by 2. And it's the one y value plus the other y value divided by 2. That's the midpoint formula. I don't know why that R is there because I don't have the original question. So
Is it -3 and 3?
no idea. No idea. Okay, SP. So the one x value is -5 plus the other x value is -1 over 2. And the one y value, top one is 8 plus a -2. I'm just going to put that in brackets. It looks neater over 2. Okay, what do we have there, Mira? It's -3 and 3.
3.
Yeah, that's good. Okay. Next one.
That's final answer. -3 and 3.
Yeah, that's the final answer.
Okay.
So now we've done length of the line. We've done gradient and equation. We have done coordinates of the midpoint. Now we have to do some inclination angle stuff. Okay, this is a problem. This sum can be a real problem because you don't have any trig background yet. So your inclination angle is going to be very difficult, but let's do that. Let's get the inclination angle. I'm just going to, I'll have to figure one out. This is not going to be easy. I want to know what is the value of the angle P. It's not an inclination angle. It's that angle there. How would I get that angle? It's a long sum. This sketch is becoming smaller and smaller. I just want to make this midpoint coordinate a bit smaller so I have more space. I don't know. Are you on phones or PCs?
Phones.
Phones. You cannot properly see on a phone, can you?
It's not so bad. Just my neck is starting to get sore. Yeah.
Okay, I want you to look at that and give me a method. How are we going to find that angle there, that small angle? Okay, while you see.
Hello?
Sorry about that. There's a phone or something that was interfering. Okay, how are we going to get that small angle? It's not that small, it's just P. It's just a drawing that's small. Let's make it slightly bigger. So I want to know how are we going to get this angle here? Well, it would be nice to have this angle here, alpha, and this one here, like beta. You see that? Then I can have the following. I'm just going to make a bigger drawing of that. So if I have this angle here, alpha, and this angle here, beta, I can get that one there at P. See that? Because this one will also be alpha. Opposite angles. And then beta equals alpha plus P, because that's exterior angles of a triangle. Okay, so the first step, you're going to find the inclination angle of QP. You're going to find this angle here. Quickly do that. We're going to do that together. Come. So step one, tan alpha is gradient. You need to find the gradient of this PQ line. We've got it already because Ibrahim worked it out just now. Remember, we have the gradient of that line. Can you remember what the gradient was? It was 1. So tan alpha is 1. Quickly write that down. Let me just get. Can you hear me now, Amira?
I
Sorry, my phone wasn't on silent. It should have been on silent. So now it's bugging me the whole time.
We can hear you.
Okay. Do you know that QP has got a gradient of 1?
Yeah.
Why did it disappear now? There we go. It's got a gradient of 1. We worked it out. So shift tan 1 is 45 degrees. So this angle here is 45 degrees. This angle here is 45 degrees. As it's small now. Can you see that on your phone?
Yeah.
We have a 45-degree angle. I need to
Yeah.
get that angle there. So please give me the equation of this inclination angle. We're going to write it as tan.
It's going to be the same.
What's the gradient of that SP line? We don't have it, eh? Remember, you need to grade.
No, we don't have it. We don't have it.
I don't think we've got the gradient of SP. No.
No, we don't.
We have to work it out. So y minus y. Quickly work out that gradient. You can do it separately if you want to. So you can say SP gradient equals y minus y2 over x minus x2. And then you work out that gradient of that line first. Then it's 8 minus 2 or 8 plus 2 over minus 5 minus 1. What's that? That's 10 over -4 now. That's the same as -5 over 2. See if you get that.
Yeah.
Yeah, I got it.
Good. Get the angle now. Now, remember from last week, if you have a negative gradient, there's something special that you have to do.
You have to make the, I don't know.
Do shift tan 5 minus 5 over 2 first. Shift tan. Shift tan minus 5 over 2. That's a negative 68,
Negative
1, whatever. Now.
68. Yeah.
Yeah. So the beta value is 180 minus 61, 68,198. So I'm just going to add 180 to my calculator. I get 111,80 degrees. So now look at that angle there. Beta minus alpha is angle P. So angle P equals beta minus alpha. That's exterior angles of a triangle. And then I have P as 111,8 minus 45. It's a difficult sum, 66,8 degrees. Okay, awesome. Okay, now we're going to do something extra. Tell me when you're finished with that.
Yeah, I'm finished.
Ibrahim. What's your surname again, Ibrahim?
Sorry, what you said?
What is your surname again?
Oh, Sharif.
Arif. Oh no,
Sorry.
the sheriff. Sorry, I forgot. Huh? You're the sheriff, isn't it? Okay, good. Now they're going to tell you the following. This is not easy. SP, let's say WQ is a parallelogram. What would the coordinates of W be? Now, that W is not on the drawing. So this is SP, and then W will be there somewhere. And then you'll go back to Q, and there. That will be your parallelogram. I want you to figure out the coordinates of W. Go. Try and figure that out. We're not going to use R in this drawing. They probably just want you to know if something is collinear. We can just test that with R. Just get the values of W first. And tell me how you're going to do that. There's various ways.
I don't know.
Okay. Amira?
No.
Okay, let's do the algebraic one first. The vertices of this parallelogram, what they do is they bisect one another so that they have the same midpoint.
Oh wait, is this the intersecting way?
Pardon?
Is this the intersecting lines?
Yeah, those
That
lines
way.
intersect, they both have the same midpoint. So it's one of your parallelogram rules. So first I'm going to get the midpoint of PQ. So PQ, the midpoint, you have to write the equation all the time. This is really schlep, but otherwise you lose a mark. So let's get the midpoint of the PQ bit. So that's -1 plus 5 over 2. And -2 is the y plus 4 over 2. And that is just 2 and 1. Okay, so that means that SW will have the same midpoint. So I'm going to set up the same equation just for the SW part. But it looks slightly different because if we add the 1x, which is -5, and add the x here, w, which is just x, and divide it by 2, we get the x value in the middle, which is 2. We got that from the previous one. So the 1x plus the other x divided by 2 gives me the x value in the middle. So -5 plus x is 4. And then x is 9. So that's 9. And then the y value, we do exactly the same. The one y was 8, plus the other y we don't have. If we divide that by 2, we get the y value in the middle, which is just 0. And then I get y as -8. So the coordinates of w is 9 and -8. That's your algebraic way. That's like the safest way to do it. Quickly make a note of that or dot that down.
Okay, I got it down.
Sharif,
I got it down.
awesome. Do you both stay in Gauteng?
Yeah.
Okay. Oh, obviously, in the same management. Okay, what about the following method? Just look at this. If I look at this transition here, I'm just going to make this smaller. Get it out of the way. Because this was 9 and something 8. There we go. Look at this transition method. So I'm going to move from that S to the Q bit, or to the Q coordinate. From -5 to 5, I've moved 10 units to the right. And from 8, I move 4 units down to get to 4. So I'm going to do the same movement. I'm going to use a move from -1, I'm going to move 10 units to the right. Then I'm going to get to an x value of 9. Then I'm also going to go 4 units down. So from -2, 4 units down is -6. No, I'm lying. 4 units down. We have a mistake here. -9 and -8. Where's our y value? I just want to check we've done it right. The y value was 8. Because I think we made a mistake. The y value is 8 and oh, this is our mistake. I put in a 0 here instead of a 1. Obviously it's a mistake. A 1. So now I have 8 plus y equals 2. Y equals -6. That's better. So this y is -6. So this one is correct now. If I move from -2, I move 4 units down, I get to -6. We made a mistake. I made a mistake here by not putting that 1 in at the y intercept, the midpoint of the y. So some people like the mechanical way, this one. Some students like the algebraic method. You can choose. This sums up your analytical geometry for grade 11. Obviously, they can play around with the sums. They can play around and make it harder. It just looks harder, but it's the same equations and same stuff. Okay, one more thing. One more thing. If I have, let's draw this axis, system of axis. If I have a line here, let's say this coordinate here is 3 and 3. This is B. And this coordinate here, A, is -4 and 5. And I have a line there. And this coordinate here is C, and it is 1 and -4. How can I determine if this angle is 90 degrees? How do we know if an angle is 90 degrees? If I take the gradient of AB and I multiply it with the gradient of BC, and I get -1 as an answer, then angle B, the angle between those two lines, is 90 degrees. So let's quickly do that. What is the gradient of AB? It's an easy way to do the gradient. You have to do the long way, but it's a change in Y value, which is 2 from 5 to 3, and the change in X value, which is from -4 to 3, which is 7. That's a gradient of, and it's a negative gradient. So it's -2/7. Then the gradient of BC. It's also the change in Y. The change in Y is 7 units. And the change in X values is 2 units. And that's a positive gradient. Okay, you could have worked it out with your formula. Eh? Gradient equals Y minus Y over X minus X. So if I multiply those two gradients, which is -2/7, and I multiply that with 7/2, then I get -1. And then therefore, ABC, that B angle is 90 degrees. And my reason is M1, the gradient, the first gradient, times the second gradient is -1. That's very important. You did that in grade 10 as well.
Yeah.
I think I saw something like that in your assignment.
Yeah, I think it's the third section. It's in there.
Yeah. Okay, that's it. That's we finished with analytical geometry. Probably next week. I just want to stop this recording. It's not necessary.